Who is Jeremiah? Mad scientist at OpenDNS Labs. I have an MS, as mentioned before, I have an MS in computer science from the University of San Francisco. Actually, just graduated recently. Previously, I worked at Mandiant, doing incident response, DNS research, Evernote, doing AppSec and IR, and also Uber, doing data science. So my career goals, I just, even outside network security, just overall, I'd like to solve interesting problems. If I wasn't in network security, I'd probably be in biocomputing, bioinformatics, or maybe kind of working on GPS tracking. I really like that stuff. I've done some Kalman filtering. I like video games, kind of, not necessarily because I play video games, but just because kind of the cool programming. Yeah, a bunch of other stuff. And a proud SPCA Pitbull puppy owner. Pretty crazy. Yeah, let's move on. So I just want to let you guys know I have a lot of stuff today, so if I go a little fast, I intend to. So basically, OpenDNS Security Labs, what do we do? I'd say, in a summary, where data science intersects network security. So big security data. DNS traffic, I'm sure you've all heard, like in the marketing, 70 billion DNS, over 70 billion DNS queries per day. And also we have HTTP traffic now with our proxy team, so 10.1 million requests per day. So our daily tasks are detection algorithms, building detection algorithms, security data analysis, distributed systems, big data engineering, and data visualization. The overall purpose of this talk is to describe one of our new models that I built, and it's called NLPRank. And at its core, it's a fraud detection system using natural language processing techniques and traffic features to identify domain squatting and brand spoofing in DNS and HTTP traffic. And this is a technique that is commonly used by phishing and APT C2s. And just to note, so when I say APT, I'm a data scientist. This is just a labeled data set. I used to work for Mandiant, so just not to go like gung-ho and like super buzzword heavy on the APT term. I'm a Python fanboy. I love Python. I use it every day. NLP, for NLP, it's great. And data science, obviously NLTK is widely known, scikit-learn, and I really like GenSim. If you guys haven't used this, you guys got to check it out. It's pretty cool for topic modeling. And it's just being developed and it's catching a lot of fire in the data science community. And so web scraping for beautiful soup and LXML. Okay, so the origins of the system. So OpenDNS Labs, when I first came there, it had a lot of detection models for commodity malware, botnet, fastflux, DGA detection, and they needed a model for targeted attacks and phishing attacks. So basically, I was assigned the Dark Hotel dataset to analyze, write a blog on, so the basic question is, how to detect evil in DNS records using lexical features of the fully qualified domain name. And not only that, validate the results. Because false positives are obviously one of the major problems among detection models. So I just want to propose this, and just to keep in mind as this overall theme for the talk, human-computer interaction. So basically, targeted attacks from a psychological perspective. If you were a high-profile executive for a company, what kind of links would you click on? What are your interests? So basically, commodity phishing follows the same psychology, and obviously it preys on like the human nature. So topics of interest, obviously money. Everybody likes getting stuff for free. Everybody likes getting money. Bank accounts, credit cards, obviously financial. That'll be one group. So then news, security software updates, which is get them all the time, and also social network. So these are the kind of brands, and like really, I want to emphasize, my model is only focused right now on the big brand names, and as you can see here. So I just want to talk briefly about the data pipeline for harnessing all that data. It's a project called Avalanche, managed by and written by senior security researcher Thibaut Hoy, and I probably butchered that, but it's a real-time system, with a streaming graph architecture. And the stream is a series of nodes, basically processors, threads, or EC2 machines, and then edges are the streams between the input and output nodes. And scalable real-time processing system. NLPRank is running currently on its authoritative logs, handles whitelisting, blacklisting, and also enriching the data. So supplemental lookups for like ASNs and GUIP lookups. So yeah. This is just a basically a graph. This is the graph architecture, but also this is shows. You can see here. So basically, sometimes we sample the data depending on when we're testing models. We can do like 0.1% or 10% of the traffic versus 90% of the traffic, or then we have a matcher for like blacklisting and whitelisting, and then the enricher node, the console here is just like a UI, so you can see it, and then we have the models. This is just like an example. So yeah, you can see like basically at each node, basically you're getting either you're filtering you have a filter on the traffic, or you're getting processing the traffic on your model. So yeah, let's delve into it. So for heuristic number 1, ASN filtering. So for those who don't know what an ASN is, basically an autonomous system number is basically, it's like your neighborhood or zip code on the internet, associated with your internet service provider, and basically a set of routers under specific or multiple routing protocols. And domains exhibiting fraudulent behavior are observed to be hosted on ASNs that are totally unassociated with the company they are spoofing. So basically, something with like Google Update that's not coming from Google's ASN, that's kind of weird. Here's some examples. So we would expect like a fully qualified domain containing Adobe to be associated with Adobe's ASN. And these are the ASNs of Adobe. And then also, like for example, Java, some fully qualified domain, for example, like a Java update that's not coming from Oracle's ASN. That would be also kind of weird. So yeah, and here's some real life examples. So in the APT example from the recent Carbonac banking Trojan, it's Adobe update, and they're coming, and also update-java coming from Petersburg Internet Network LLC in Russia. And usually, basically, why aren't they coming from Oracle and Adobe's ASNs? And same thing for the commodity phishing examples. Security check PayPal. Why is it coming from eBay's ASN? Yeah, which is typically what PayPal.com would be on. And they're coming from Cirrus1 and Hostway services, and these are common perpetrators. The usual suspects, yeah. Cirrus1 is the top. So this was taken stats from Phishtank. So these are the top like offenders for phishing sites. Cirrus1, Unified Layer, OVH, GoDaddy, and obviously, yeah, the usual suspects. We see these all the time. I'd say Enom too. Yeah. Okay, so first step, yeah. So we want to take a big chunk out of the traffic because text processing is computationally intensive. So work with Dia on this, and we work with a lot of ASN data on at OpenDNS, and Dia Majoub is a PhD in graph theory. He spoke here last year, actually. He does like fast flux and ASN analysis. So basically, authlogs come in, we have the enricher node. We'll do a lookup on the on the IP and get the ASN and include it in the logs. So basically, we create a mapping of brand names to the legitimate ASNs and basically look up domains as they come in. And if they do not come from those legitimate ASNs, we just throw them out. So we don't want anything coming from Google, Yahoo, ASN. We just want kind of the lower ranking stuff. So here it's a heuristic number 2. So now we get into the kind of like natural language, beginning natural language processing aspect. So defining a malicious language of the internet with within fully qualified domains. So first thing I did, and I always do as a data scientist, is build intuitions. Eyeball the data, run basic metrics. Just get a good grasp of the data. And I can't stress that enough. Oftentimes sometimes I just start writing code. I'm like, wish I went back and ran metrics in the beginning. So basically I extracted important words and substrings in the APT data sets. I found kind of that APT domains exhibit similar lexical features to commodity phishing domains. So it's important to look at the co-occurrences or bigrams and trigrams within these domains. You could basically go through the domain and look at look at the substrings and find if basically, for example, take dictionary words. Just throw the dictionary at it, extract whatever words are in the dictionary. Look at that. That's kind of interesting. From the APT data sets, extracted words from the dictionary and applied stemming, which is a text processing technique to basically get the root of the word. So here are the top counts of the APT data sets, from the dictionary words. So you could see mail, news, soft, which is like software, server, update, game, online, auto, port host, free, login, link. Kind of interesting, right? And with bigram collocations, so basically the co-occurrences, words that appear often with each other. Adobe update, update-Java. This is a common theme. There could be McAfee update, McAfee, -secure-server-update. The list goes on. So the idea is that you have a brand name, and what I term is it's called. This is my own made-up word. It's an advertising action word plus the TLD. So what I mean by advertising action word is that they're advertising something to the user. Like again, going back to human-computer interaction. Why would you want to click on the link? So for an update, software update, security update, and execs don't know. Yeah, they're not targeting security people. They're targeting like execs. So here's some examples. So AdobeUpdates.com. This was the dark hotel, and I don't need to go into that, but basically, Kaspersky released a report of hacking hotel Wi-Fi. Anyways, so AdobeUpdates.com, AdobePlugs.net, AdobeRegister.flashserve.net, Microsoft XP Update. So you could begin to see the trend, and here's from the APT1 report by Mandiant. Gmail boxes, Microsoft Update-info, Firefox Updata. And the bottom one, Firefox Updata, is one of the reasons why I use stemming, because that wouldn't be caught by just using update. So I need the root. Okay, so basically, creating malicious language derived from the lexical features of the APT and phishing data sets. So I built Corpus out of these domains, similar to examples in the previous slide. And basically, I have two dictionaries, one of brand names and one of these, add action words. So the reason for stemming I just said. So then a full string match is good, and it gives back great results. And more often than not, they use that. But also, I use the edit distance algorithm. So if there's like a one-off, so if it's like one LinkedIn.net versus LinkedIn, .net, Wells Fargo with a 1 at the L's, Google with a 00 for the O's, which is common. I'm sure you guys have seen. So yeah, minimum edit distance overview. Just back to the algorithms class. So shortest path, dynamic program algorithm checking similarity between two strings. Think spell check. So widely used in many fields, for example, bioinformatics for DNA sequence alignment. How many operations or edits it takes to turn one string into the other. So yeah, just think of string similarity. Initial state, string to transform. Operations are insert, delete, and substitution. So the goal state is the final string, and the path cost is the minimum number of edits. So the initial string, for example here, and I'm sorry it's not lined up, it's annoying. So basically inception turned into execution. So there's 5 edits, 3 substitutions. So from insert to I to space, it's a deletion. N to E is substitution, C to X substitution, blank to C, it's an insertion, and P to U is substitution. 5. So Google here, 2 edits, 2 substitutions. O and O to 0, 0 in the Google domain. So here is the next step. So we have that first edit distance on the domain, and that could also be applied to URLs. So here, next step is I want to recreate the researcher's mind by analyzing the HTML of the page. And again, I want to apply the edit distance as a previous step, because lookups are costly. We want to minimize, whatever, basically consuming resources. And when reviewing the malicious domains, what is typical methodology for review? Visit the site in the Tor browser. The researcher processes the information on site, looks for clues, and gains a summary of the page. Then they make a decision whether the site is legit or malicious. So specifically for phishing sites, for human computer action, what makes people fall for this? What makes people fall for phishing sites? So usually it's just straight up copy. Sometimes they'll use tools. Other times they just grab the code from the site. So how can we automate this process? How can we recreate the researcher's mind? So can we apply document similarity algorithms? This is document similarity algorithms already been solved. Like for example, search. So yeah, again, human-computer interaction. Examples from an Apple phishing page. So why would you think it's a phishing page? Because you look and you see like title, you see links, and oftentimes they'll link back to the legitimate site. For example, if you click on the careers in a fake phishing PayPal site, click on the careers, it linked back to like dev careers at paypal.com. Images, obviously, visual cues. So yeah, other clues within the source. So this was an example of found from a PayPal phishing site. They're using actual, I don't know if you guys could see it, but basically a tool called HCTrack, which basically clones the whole site. And this is kind of more obvious, right? So we can look for little markers like that too. So yeah. So after we grab the content from the page, we need to kind of pre-process it and prepare it for the algorithm. So let's clean the data first, strip punctuations, symbols, unnecessary content. Sometimes it can take out numbers. Sometimes the numbers are important. Normalizing the data. So we need to normalize it kind of across the board. So you apply stemming. And I also, I spent a lot of time on this, so I did some kind of data encoding because I want to include, the certain terms, basically for links and sometimes images. I want that as for example here, as a google.com, I want it to have a Google link because the algorithm will be used, that we were using relies on this. So it's harder than it seems. It's just, I spent so much time beating my head against the wall. I attended like natural language processing talks. Basically, they were like, you have to write your own parser, which is annoying. But yeah, it's just, that's what I had to do. And I'm still in the process of doing that and improving it. So non-trivial, yeah, dealing with malformed tags. Web data can be a huge just barf of HTML. So yeah, sometimes lose data dealing with HTML and JS with third-party libraries, which tags to encode, title, links, images. That's what I started with. And I applied basic natural language processing algorithms like TF-IDF. But again, I need more samples for training. So yeah, so the overall, in the beginning, when you're just using TF-IDF for the HTML content, and I was even just hitting on the actual like edit distance part, I was finding a lot of success. I mean, obviously there's a lot of false positives in the beginning, but with the tuning and stuff from the HTML content, I was able to limit the false positives and actually proactively go after false positives. For example, you might think, if it's a Windows site, if say I'm looking for Windows in the domain, and it's actually a site about windows and doors and furniture, the keywords from the TF-IDF would come back with furniture, windows, doors, so I could just throw those out based on those. Same thing with Apple, right? Apple might come back with fruit and other like market, so I could throw those out based on getting the content of the page. So I'm proactively going after these false positives. Java, same thing about coffee, rather than, or sometimes Java tutorials, so I could throw those out. Yeah. So yeah, success in identifying these types of attacks, and also identifying other stuff too. Yeah, new stuff. And here's some examples. So a Carbon Act, the banking Trojan from Conspiracy Report came out in February. You can see here, and you don't have to believe me, but here's the timestamp, 123, and update-java. And obviously that's a C, so false positive are there. But update-java.net. So that was kind of exciting. And that only came back as a high risk. So I use those terms because often update it would be considered high risk with a brand name. So yeah, interesting results, leaning from Guangdong, Alabama. So yeah, this is kind of, yeah, along with the Primera attacks. Yeah, obviously all those domains, crazy. And Sakula, so this was in the Sakula report, same thing, that leaning email. I'm just going to go through a little fast because I have little time left. So yeah, found these two, which are also associated with the Blue Cross Primera, and didn't catch these, but I will be able to. I was able to find parking pages, similarities between parking pages, and you can see here the suspended pages, which is also useful. Here's some phishing sites. So yeah, I want to talk about Phishtank data. This is Phishtank is a huge cult following in the community. I always get asked about Phishtank. Basically, yes. This is a whole repo. It's basically like a giant training set for security data scientists. And examples, here's an example of false positives in Phishtank. So I want to limit the false positives. This was where I was now testing on HTTP traffic because Phishtank deals with URLs. So the hypothesis, similar to the way Netflix recommends stuff, I want to basically identify phishing pages using IR topic modeling techniques and auto-label Phishtank submissions as they come in. So yeah, this is kind of overview of how machine learning works. Corpus, text documents, converting to vector space, and turn to a machine learning algorithm and predictive model, and you output your expected label. Kind of followed this. So I used GenSim for topic modeling, which is awesome. I mentioned that before. Topic modeling, basically you're trying to understand themes, concepts about documents. So yeah, I want to understand themes of HTML data content, and basically it's great for building recommender systems and great for using as features for a classifier. So yeah, built the corpus out of the brand names. Yeah, again, focused on the big name brands, seeing all kinds of phishes, 90s, 2000s, PayPal, 2015, Christian Mingle phishing. So again, yeah, so then I started using TF-IDF. So first I get the counts from the page of the terms, and then I convert that to TF-IDF weighting. Yeah, basically I want to see not only if the term is frequent in the document, but how rare it is across all documents. Yeah, and this is the formula for it. Yeah, again, you know, sometimes the term might be, in one document, it might be a high occurrences, but it's still, we want the rarity, we need to factor in the rarity over all documents. So yeah, then I use also the cosine distance. This is a way to measure the similarity of documents. Yeah, and basically give a recommendation. Normalized dot product of the vectors, basically converting the word counts. Yeah, it's basically once you convert to the TF-IDF like vectors, then you could compare cosine similarity. And we're going to apply another algorithm quick too. So yeah, here's going back to grade school math, geometry, SOHCAHTOA, cosine distance, and here's basically adjacent over a hypotenuse. So then I use latent semantic indexing, and I'm sorry I'm short on time, but I'm just going to go real quick over this, but basically using singular value decomposition, which is basically a lot of nasty linear algebra, basically identifying concepts and identifying clusters. And one of the drawbacks is it uses the bag of, well, first it uses the bag of words technique, but one of the shortcomings of the bag of words technique is that it only looks at one word, so basically there's no ordering. To kind of help normalize this, I use bigrams, trigrams. So yeah, input basically X matrix where M is the number of documents, N is the number of terms. Do the decomposition, have to pick K, which is K is the number of concepts. So yeah, just kind of matrix transformation. U is the matrix of documents, K concepts. S is the basic K by K diagonal. And then the V transpose is an M by K matrix where M is the terms and K is the concept. And we're most interested in the V transpose because this is which terms make up a concept or topic. Yeah, here's just an example. Basically some titles on the left, books, and you can see the clustering, stock market, value investing. Basically, these are the kind of terms that go along with the concepts. So yeah, here's getting great results. So sample output, basically, this is how it comes in. I take the top 5. The input page is a Wells Fargo. Then we have basically 500, and those are the documents from my corpus that are most similar. Same thing, here's input Chase URL, and Chase is the top 2, and then close to Bank of America. And this is interesting, I showed this because it also falls under the idea of basically, it's the same kind of topic, right? Financial, because oftentimes banking sites, even though the name might be different, they'll still have this similar like words, like insurance, you know, banks, finance, and so that's why it's coming back, and so that's kind of interesting too. Let's say if we saw a phishing site for a bank we never seen before, or we're not familiar with, some bank in Timbuktu. So yeah, here's getting down to the numbers. So 423 total samples, 70 in the corpus, 345 test. So basically, going back to this slide, so at the top, right? So for the time being, I'm just taking the top, but also I'm factoring the top 5. So 314 are hitting as the top recommendation. So at the top, like Wells Fargo, number 1. 16 out of the remaining 31 are in the top 5. So we could just do a little bit of weighting to kind of move those up, percolate those up. So kind of like 330 out of 345, which is pretty good. And I'm pretty happy with. Some brands have a higher accuracy. Like when there's nice, juicy HTML, oh man, it works awesome. Wells Fargo, like fishes, like I have nice, juicy HTML, and it hits like pretty much like 100% of the time. Here's some like more data science statistics for you data science out there. And this is ran actually on the only factoring if it hits on the top. So not factoring the top 5. So beyond Phishtank, I'm just going to go through this really quick, only a few minutes. So DNS data is not the ideal match for this. HTTP traffic is a much better fit. Why? When doing lookups, landing on the index page, like for example, I see CGI bin and PayPal.com. So then I'd have to go and hit PayPal, the PayPal phishing site and go there. The PayPal security-update.com. So within DNS, if I was just focused on DNS, I'm going to do this. I'm going to build a web crawler. But for right now, I want to make sure testing sound, and we're going to use the proxy, which is one of the OpenDNS not really known for, HTTP traffic. So yeah, so the intelligent proxy, awesome team, man in the middle. So the gray list, sometimes like we won't blacklist the entire domain, we'll just put on the gray list, and certain URLs out of that domain will be blocked. So next step in next generation in OpenDNS security. So here's some examples. You guys got the point of these ones. Here's the Wells Fargo. You can see from it could be applied to URLs too. Wells Fargo-online.server. Wells Fargo online, yeah. And then here's the edit distance, Wells Fargo. Yeah, so here is the pipeline. Okay, cool. HTTP traffic, whitelisting, ASN filtering, popularity check, and this can also be applied to Phishtank if sometimes those google.com.pe, could be submitted. So do a popularity check, and we have an edit distance. Then we do a GET request, and again at the top. So red is acquiring the data, green is filtering, blue is NLP, orange is output. So yeah, do the GET request, counts of words on the page, use TF-IDF for weighting, do latent semantic analysis, compare cosine similarities, take the top end similar documents, add it to the block list, auto tag brand/topics in Phishtank, email daily results, and build training sets periodically, retrain Corpus, fetch legitimate brand sites. Okay, and I just went through this. So yeah, the conclusion is kind of at OpenDNS, I like to term it like putting my PM hat on. It's agile research, building, testing, tuning, iterating. Need to experiment with more structure of words, like you saw that Wells Fargo. So applying regexing and like automata theory. Yeah, I mentioned agile research again. So additional feature engineering, data collection and building Corpus, filtering false positives, and patent this. So that's it. Questions? Yeah. Oh yeah. So basically, yeah, we kind of like one of the things that's been kind of messing with our like parsers is like puny code stuff, and then like those things always cause problems with like especially third-party library parsers, and definitely more for like URLs are all kinds of crazy stuff, but domains are more kind of only problems I really have is for the puny code stuff. Yeah. Yeah.
I know a lot about phishing links that they get removed and things like that.
Pardon?
Like, like how the phishing links, they always come out, weird things and all like this. Do you have any data behind how fast they get removed?
Oh, yeah. So like time between takedown. Sometimes between like we don't really have that kind of data. I guess that would be a good kind of study. But yeah, that's kind of like interesting. Yeah. But we're kind of reaching out to certain like service providers and basically saying like, can you take down the site fast? And like even reaching out to like PayPal and kind of different like companies. Yeah, Apple. So indexing.